Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
These days, most applications available on the web are expected to have an API or application program interface. Not only do web front ends often need API access, but APIs are increasingly used by clients as well to integrate with other applications they have. In this episode, we're going to discuss some anti-patterns that are common when building an API, as well as why they aren't the best ideas. If you're building an API for the first time, the content here should help you out. And if you're building an API for the 500th time, the content here should help you out. But before we get started, Will, what's been APing your eye? I don't know.
Helping me out.
Helping you out. Yeah, that's even better. Yeah.
Yeah. So I've been going through a Pluralsight course this week on React and Redux. It's actually been very helpful for understanding kind of the innards of how Redux works. We're using React at work. We're not using Redux currently because it's code from a previous vendor. Let's just leave it there.
Yeah.
It's been pretty interesting. Actually, after having someone really explain it in depth, a lot of things make a whole lot more sense now. Because a lot of the docs and stuff I was reading, is talking about all the thunking and all this stuff that's going on. And like, what are you talking about? And it just is nice. It's helpful. So other than that, I haven't done much. I'm just like, I'm either working or I'm studying right now.
Yeah, I get that, man.
Yeah. So how about you?
Well, as you can see, my keyboard is uncovered because I've been doing a lot of practice. I'm playing a lot. We have a conference coming up, not this Saturday, but next Saturday, and I'm on the worship team for that. So that's an all-day conference, and we've got 3 different worship sets. So 8 songs? Yeah. So 1 set of 2 songs and 2 sets of 3 songs. So yeah, kind of exciting. Most of them I've got memorized already, and it's just reviewing them. There's a couple that I haven't got quite down yet, so I'm working on those. And then I just bought 40 pounds of chicken wings this afternoon.
I've got a good 20 in my freezer right now.
Yeah.
It's nice when you catch them on sale.
I went to Sam's because we've got I caught them on sale last time when I had a cookout, and I smoked the wings and ate on them for like a week, and it was so good. Well, we're having a church picnic next Saturday. And so I'm going to attach the smoker attachment to my grill and smoke these Friday. If the weather's nice enough, it's supposed to rain tomorrow, but today's Wednesday, by the way. We're recording a different day than normal. So if it rains Thursday and dries enough Friday, I'll probably mow the lawn too. If not, I'll just cook my chicken wings in the grill or smoker. So I've got 40 pounds of chicken wings to smoke for a church event, which is going to be pretty cool.
Yeah, I did that. Well, I didn't do the, for a church event, but I'm trying to think when it was. I want to say it was like a year ago. I was in Costco and they mismarked the chicken thighs for like $1.60 a pound or something. I was like stupid low. And yeah, I walked out of there with like 40 something pounds chicken thighs, and then had to use the vacuum sealer and get them all prepped and packaged up. And I still have some of them in the freezer because it takes forever to eat that many.
Yeah, I need to get a vacuum sealer. That would be really useful. So
get the one like I got, because I had like one of the cheaper ones. And the thing is if you're sealing a bunch of bags in a row, they heat up and then they don't, like the heating element gets too hot and it'll stop working. Whereas I've got a commercial grade one and it's well worth it if you're doing much of that at all.
When I get around to getting one, I'm not in a rush right now, but yeah, I do plan on getting one at some point. But yeah, I'll be cooking that for the picnic. I mean, you guys are welcome to come down. I know you don't travel very far in your car because it's not the best shape, but
yeah. And there's no air conditioning, and this is Tennessee.
It's not supposed to be that. I think the high is in the like upper 60s, low 70s. So, but yeah, it's noon to 3 at the park down the road from the church near where I live. So yeah, you're absolutely welcome to come, man. It'd be a lot of fun. You'll know a lot of people there because you met them at my birthday party and stuff like that. So that's what I got going on.
Saving money is hard, especially when Costco has chicken wings on sale.
Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at Complete Developer Podcast, he focuses on helping you to not only establish a real plan, but also to take action so that you can live your best life. I mean, look, when you get financially established, you don't sit there at the grocery store and get mad at the price of things like chicken wings and beef jerky, right? That's the goal, is to get to there.
Yeah. And to get there takes a little bit of work. Investing in financial planning services really comes down to whether or not you can improve your finances and get to the point where you can buy 40 pounds of chicken wings. I don't know why we're harping on that. But with the help of Level Up, the compounding impact of making those better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And guys, best of all, Lucas is a fiduciary for his clients. What that means is he's here to help guide you to a better financial solution, not someone just trying to sell you a product. That's not what he does.
Yeah, and if you want to see more of what he does, you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face, and he interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com.
APIs are a huge part of development today, and one of the most common types of API out there is the RESTful API. Yeah, I did that on purpose. REST stands for representational state transfer, which is a software architecture that imposes conditions on how an API should work. Essentially, it was created as a set of guidelines for how communication should work between disparate systems on a complex communication network, such as the internet. REST is implemented on top of HTTP and uses the standards in the underlying protocol as part of the standards for communication. In a RESTful API, client and server applications are considered to be independent, as in details from one should not leak into the other to the extent possible. I mean, we live in a messy world, not in a perfect world. This also implies that API calls for the same resource should look the same regardless of where they come from. Actually, this is required to decouple the client and the server.
RESTful APIs are built around the inherent statelessness of HTTP. That is, a persistent connection between the client and server is not assumed. This has pretty profound architectural implications in regards to how resources are accessed and mutated. In order to make this disconnected architecture perform well across the internet, this also means that caching is going to be used heavily. Caching implies further architectural constraints around resource access, as well as careful coding server-side to ensure that items are cached and removed from cache appropriately. This helps both client-side speed and server-side scalability. In addition, the lack of a session makes it far easier to spread a workload across multiple servers because there's no need to synchronize state between them or to keep sessions sticky to one server. And I think that's something that a lot of newer web devs don't remember this, but like in the early days when we were scaling stuff, you would basically try to kind of have things like session tokens that only connected to one of the servers in a load balancing rotation so that it didn't have to replicate across all of them in the load balancer. That worked okay, I think, for a while, but a lot of times you would run into stuff where one of those servers would go down and all of a sudden somebody's session is broken and a bunch of other people's are completely fine, and it's actually not very helpful.
Oh, yeah. No. In this episode, we're going to discuss some common mistakes that people make when building a new API, especially when they haven't done so before. Most of these mistakes are pretty understandable and are things you learn along the way. However, mistakes on an API surface can be extremely annoying and expensive to correct, especially if you already have a lot of API clients. It's better to avoid these issues from the outset. while the fix for some of these issues sounds worse than just dealing with the problem, we strongly encourage you to fix these issues before you get a lot of clients who are used to them or before your system scales to the point where these issues break things. Also, this is not just for new developers. A lot of times, hearing these things, it's stuff that if you've worked even as an API developer for a long time, you may not have faced something that we're going to talk about in a while. And so it's a good refresher for you guys. I've been looking forward to this episode ever since Will told me he was going to be writing it, because I'm like, man, I've been doing APIs pretty much all my career. Only when I became a lead did I really start doing a lot more front end stuff. And even as such, like, there's a lot that I can still get from that. And I know Will has learned stuff while writing this too.
Yeah. Well, and I mean, I'm dealing with a lot of API stuff at work and also dealing with the front end calling it. So, like, I can't dodge like I used to. At the previous gig, I was mostly on the back end because the front end was really heavy Angular stuff.
Mm-hmm.
And they realized it's like, hey, he does way better just doing API database stuff. Just don't put him on the front end. And I can't really avoid it now. And I'm also dealing with API interactions, mostly in GraphQL, which has similar issues, but even more annoying in some respects. But not just talking to things with a web front end. So having a WPF app that is attached to a handheld scanner.
Yeah. I find that fascinating. Like, I would enjoy that kind of work.
I'm
not saying it's easy. I'm just saying it's the kind of stuff that I think would be interesting, because pretty much my entire career has been web apps.
Yeah, it gets interesting trying to trace things because, like, I don't have a scanner. I have an app that's an emulator for the scanner, and it serves it up over TCP, and then something the WPF app can talk to that and try to assemble things to make a web request. You just kind of run into stuff that's like, oh, this is a slight difference. It's also weird doing GraphQL calls from .NET. I'm very used to it in JavaScript. I have no problem doing it in JavaScript, but from .NET, like, I look at it and it just makes me itch because it's not what I want.
Yeah, it's not what you're used to. And it's not really, I don't want to say it's not built for that, but it's really not built for that.
It's more like, I wouldn't say that it's not built for that because, you can kind of do it in a sort of linky type.
Yeah. Like, it's not that it's not built for that. It's just, it's not
idiomatic.
Yeah.
For .NET, for the way that people have typically done things.
That's a good way to put it.
And then you put WPF's inherent weirdness on top of that too, with some of the component stuff. And it just, you're like, man, am I still doing .NET? Is that actually what I'm looking at right here? And yeah, so I'm having to switch between that and then Node and React and the occasional bit of MySQL. So yeah. But anyway, back to the API funsies.
Yeah. So before we get started, just something that we can both say here from experience, that a lot of these anti-patterns that we're going to talk about don't really cause a lot of problems at first. And they don't seem like much until suddenly they're a huge issue. And it's just like, boom, it hits.
Yeah, these are phase shift type things in a lot of respects. I mean, a couple of them are like, hey, this is always dumb. But some of them you get away with, especially in the dev environment or even, in a light production environment. And then you get a big new client or a client that is geographically separated from your data center in some way. And all of a sudden, just systems start doing weird things. So the first one, the first mistake is one that is probably pretty much always a mistake. And that is failing to use HTTP verbs correctly and consistently. The verbs, such as get, put, post, delete, and patch kind of have specific and well-known idiomatic meanings to anybody talking to a web API. And you need to use the right one to indicate what the method does, because there's kind of a set of expectations around how something's going to behave.
Right. A good example is a get method that actually changes the data each time it's accessed. The return value can't be cached, and the behavior is not intuitive.
Yeah, and by changing data, we mean the resource being directly accessed. So, for instance, if you're like, I'm pulling this medical record down, well, okay, that's going to change data, right? You have an audit trail that's getting written, but it's not on that resource.
Right. On the other side, I've seen, I remember we've had conversations on the show about searches, whether they should be gets or not, because you're passing in a big search object. And do you pass that in the query or the header or as a get, or do you pass it in as like a post or something? And so I've seen that. I've also seen not a search, but where it's like, hey, we need to get information. Literally, it has get in the name of the method call, like the endpoint has get in it, but it's a post because they're posting the user and page data, so like pagination data, to the API. And it's like,
Yeah, that's not what that's for.
no, that needs to be a get and it needs to be passed in differently.
Yeah, well, especially like the searches. If your searches are not complex past a certain level, put it in the query string and be done with it. But I have seen situations where it's a fairly complex query and you do have a limit on what can be in the query string. Of course, arguably, by that point, you're also doing something complex enough where you go, hey, this is actually an out of band job and I'm posting and creating a new one. There we go. And you just call it something else and you just introduce a new concept there and now it doesn't surprise anybody.
Yeah, I mean, you get that complex, you're gonna need to do something like that. Yeah.
Yeah. Well, and a lot of times too, it may also be a situation where do I really need crazy complex search capability here, or do I need another endpoint that does something like GraphQL so that I can cut back on the amount of crap I'm pulling back?
Mm-hmm.
Because I mean, that's the other thing too, with not necessarily with REST, but was it Hate OAS? Like where they really get into not just returning an entity, but saying, here are the fields I want from this entity. Well, if that's part of your get, how much of that can you cram in a query string? And the big problem is with gets, you're not going to have a post body, which lets you cram all kinds of crap in. So that's just something to bear in mind.
I've worked with systems that were designed that way. Not the current job, but the last one I had. Yeah.
Well, and this is something you'll also see from a lot of really old frameworks where they didn't have REST idiomatically understood, I guess. So for instance, in .NET Web Forms, a great example of this, with Ajax functionality early on, it was pretty much always a post because you posted to a web form that then processed whatever you were posting up. And like you're cramming a bunch of page state at that endpoint because it's got to reconstruct the thing and then build the piece that you need to pitch it back down to you. And so you will still see this sort of stuff around, but it is fading away over time. And we used to hack the crap out of things too, because there was not anybody telling us, hey, dude, this is not the way this works. You got something working, and that was across the organization after that, whether it was a bad idea or not. But yeah, you need to note that the correctness of the verb in a particular situation is understood to be from the perspective of the client, not from the perspective of the system itself. So it's like, which hand is the person's right hand in medicine, right? You go, it's always from the patient's perspective, because otherwise you cut off the wrong limb. And you kind of have to do the same thing here, because if you're looking at it going, oh, what is this a get or a post from a system's perspective? It's from whoever is making the call. For instance, if a soft delete removes an item from visibility to the client, it's still okay to use the delete verb, even though the record isn't really gone from a sysadmin perspective. It's gone from the client's perspective. And I think the medical example probably is a reasonable way to think about why that's correct.
That was a good one. Now, the whole thing can get a little opinionated when exploring the difference between, say, a put and a patch. And like I mentioned, it can get tempting to make searches a post. We had that conversation before, even though they really belong in the get. And I've seen where other things that were not searches, but they had to pass in information that wasn't like one or two values. And I was like, all right, this should be a get, not a post, because...
Or they don't want it in web browser history. That's the other thing I've seen is like, oh, this is a query string thing. And it's something stupid like their username. And you're like, well, I don't want that in the web browser history for some reason. And so I'm going to try to obfuscate it by putting it in a post body. By the way, that is bad security. That doesn't fix the things you think it does.
Yeah, no, that doesn't actually obfuscate it really that well at all. So, yeah.
And we'll get into a minute too why that's probably not something you want as part of a GET request.
So the next anti-pattern is failing to cache appropriately. Caching is critical to performance if your system is under any kind of load, but it's really, really easy to get wrong. And there's a lot of smaller anti-patterns within caching itself.
Yeah, I mean, it's honestly a whole subject on its own. If you're really good at dealing with Redis or Redis, I've heard it pronounced both ways, that's a full-time job in some organizations because you got to deal with a lot of stuff there. If the data being cached includes data about the current user, like we were talking about a minute ago, then you're making a mistake if the cache key for that data isn't user specific, right? If you have a route that's /me/payment methods, and dude bro A makes a request, gets his payment methods, and then dude bro B hits the system and gets A's cached request, then you just had a identity theft potential breach.
Yeah.
And so you got to be really careful about that. And that's also why you don't want to include that in a URL, without security that locks stuff down, because a lot of times people will say, oh, I'm going to send this URL of this thing I'm seeing to support or to somebody else. And if you're not checking things cleanly, you may get data back that you're not supposed to. And there are still systems in the wild like that. You'll see them on the news every so often.
Also, keep in mind that the cache has to be fast, accurate, as in it gets invalidated when something changes, and compliant with regulations, especially in terms of data safety and security.
Yeah. I've seen a couple of instances where people will use services that are either not meant to be a cache, like a MongoDB instance. They go, hey, I'm going to cache in a document database instead of doing a bunch of joins in my main database, and kind of use it as a poor man's cache. Or they'll have a caching instance that is not properly secured. And well, if somebody can get in there and enumerate the keys, they can get into all kinds of stuff. And that is not as secured as the rest of your system. That's now a failure point from security. And you could get in real trouble with that. The accuracy thing is also important, because if you cache something for 24 hours, well, for one thing, you're going to overload your cache system if you do that with everything. But if something has changed, when is that change going to be made available? Some of that may be just, hey, I need to fire off a cache invalidation and kick that sucker out when the item changes. Some things are cached all the time, like enumerated constants, for drop downs and things that are always the same when the system's up. And it's okay to cache those for a while. Some things you may only want to cache for a minute, just because, hey, there's going to be 3 or 4 subsequent calls that are maybe going to use this. And so you need to think about the life cycle of the data that you are putting into cache, as well as like how it is stored and protected on disk, or if you have a persistent cache, and what kind of access patterns you might have to the memory of the caching server if it is not persistent, or even if it is persistent for that matter. Because, for instance, if you have your cache server in a situation where it's on another machine and you don't control, like it's in a VM somewhere at some crappy data center, and you don't have any legal restraints around who has access to that hypervisor on that VM, they can get in and get stuff. So you just need to think about that just like you would any other piece of your system. Like, don't think of it as, hey, it's a dumb cache. If it's a cache on your system, like, you really, really have to be careful about that.
It's often advised to cache the results of frequently used queries on system startup to avoid lag. However, this process can make for slow starting APIs as well. It really only works well if other infrastructure is in place to avoid downtime.
I've worked on several systems like this where there's a lot of stuff that needed to be cached. Like, we really, really served a lot of things out of cache, because to get the database servers that we would need for all the traffic that we would sometimes have in bursts, that just wasn't, like, the product couldn't exist. And so we would have to preload the cache. And gets interesting if those queries are slow loading the cache up too, because I know in one system, we'd get the server spun up and then we had a script that would go through and hit all the things in the cache to get everything loaded. And then we'd kick off another script after that one just to try to keep everything hot, essentially. That is not a good place to be, because, I mean, the way that things were cached, it was like, if it hasn't been accessed in this amount of time for some of the items, then let it fall out of cache.
That makes sense.
Which under load was fine, because it's like, hey, this is kind of static data, but it really didn't turn out to be a great strategy. And I think we ended up replacing that. That's, yeah, some of the same people at that gig and another gig. So it's kind of hard to remember which one was which. So another thing that will get you is incorrect application of error codes. There are a lot of APIs out there that will return an HTTP 200 status code and then include an error message in the body. Bad programmer, don't do that. I mean, seriously, I will roll up a newspaper and smack you in the nose over that. That is not cool. Don't ever do that. That's just not how HTTP works. And it really should be either a 400 or 500 series message, depending on who screwed up.
Yeah.
And I've done that, by the way. Like had an API that back before I really understood how this was supposed to work. I did that and then had to integrate with it later and was not happy.
Yeah, back when I was a junior, one of the other juniors built a system that ended up getting. It was more of a proof of concept and supposed to be very specific to one purpose, and management at the time kept tacking on more and more stuff to it. So when she wrote it, she did that, and it was always such a pain because you couldn't rely on the errors. Like you couldn't rely on a 200. You had to look at the message body and go, all right, hey, is it actually in the format that I need it to be? Or is it a string, which means it was an error message?
Yeah. And you used to see this a lot back in the day before structured error handling, with try catches, where a function might return a 0 if it went successfully. It did its side effects wherever else it was going to do them, or otherwise it would return an error code. And you had to look at that and go, okay, what is this? There's a reason we got away from that on the back end and on just general programming. It's the same reason that you want to get these right on a web interface.
Oh yeah, it was such a pain. And as soon as the big project that I worked on was replacing that with an actual architected system. Again, in her defense, she built it as a proof of concept to say, hey, we can build something. This is a very small little thing to do one specific thing. And then management was like, oh, well, we've got this thing. Let's just add on to it to make it do this and this and this. And it never got properly designed and built out. So it wasn't, oh, she's a bad programmer. She's actually a really good programmer. But
well, and that's why she wrote the prototype quickly, because she wasn't going, oh, this is going to go into production. She's like, hey, I want to get this idea out here. What happened was not congruent with her initial goal. I've had that happen to me plenty of times, and you can't do anything about it. And that's really why you want to avoid these things early too. If you're ever doing a prototype, just don't cut these corners, because the business people will not get this.
You also want to be sure that the error message correctly indicates what is going on. For instance, don't return a 404 when you actually got a server error, as that can lead the client to an irritating wild goose chase. Oh my goodness, so true. I have really been working with my team on this, because we initially had a separate team building the API for us. And so when we came in, a lot of it is just returning a 500 server error, where I'm like, let's start using these errors to go, hey, this is actually, we didn't find anything when we tried. Let's do a 404 not found. Let's do these actual codes to send it back to the client. And then from there, we can give a more detailed error message than an error occurred.
Yeah.
We haven't got it everywhere in our system yet, but the whole team has been sort of picking up on this idea, and it's actually starting to get a little bit better for both QA and the users, because they're like, oh, hey, this is what happened.
Yeah, and it's also probably a bad idea to cache error messages in most situations. Frankly, I can't come up with one off the top of my head where you'd actually want to cache it. Unless it's, maybe a system status thing. It's like, hey, the system's down. Let's cache that and poking the system. But most of the time, you're going to handle that with some other mechanism. Just, understand that if you're giving an error code, then whatever that is should not be cached, and whatever payload comes back should not be cached. In most cases, I guess I can think of one maybe where it might be something worth doing. If there's a risk of it being a target for a DDoS for that kind of error, maybe some kind of caching strategy might kind of keep it where it's harder to hurt you with it. But even then, I feel like that's really not the intent here. Like there's other software for that. You're not writing security software most of the time.
Right. Now, when you're talking about poking servers, it makes me think I want a server named Bear.
Yeah.
So I can just poke the bear.
Right.
Sorry. I couldn't help it. That was bad. That was really bad. Yeah.
Yeah, write that joke down. Speaking of writing things down, another mistake is lacking documentation. Your API should include written documentation written for human beings, not like the old MSDN thing that was like, here's a dump of all the functions we have, but, actual, like, here's what you do with it, along with sample usages of the system. And you also need to have code-based documentation. So things like Swagger.
Oh, Swagger's great.
Yeah, that a machine can read and potentially build a UI for it or build a wrapper for it. I mean, that was one of the things that I really, as much as I like to bash SOAP and how it got overly extended into wild lands unknown, one thing that was really nice about it was you got a schema back and you could go, hey, here's how I wrap this API. And I can actually make a client for it programmatically in an IDE so that I'm not having to write all this low-level code. And that's still possible with RESTful APIs too.
Now, if you don't include proper documentation, you can pretty much count on people poking at your API and trying things. Again, you should name it Bear. At least some of those things will waste system resources and lead to errors. Ask Will how he knows.
Yeah. I mean, when somebody's trying to talk to your API and they don't have good docs, they are going to try things. And you're going to start seeing them in the logs. They're going to set off security systems. You really want to make it so that if someone is there with good intentions, that they can move forward safely with those good intentions, rather than making you think that you're under attack when it's actually, dude, bro, just can't read your crappy docs. I've been using the word dude, bro a lot today. I'm not sure what the deal is. And a lack of documentation also makes it harder to integrate with your system, which means that fewer people will attempt to do it. If you're offering an API, that's probably not what you want to happen, right? Even if it's a paid one, it's like, hey, yeah, pay for the API. As many people that want to pay, let's let them pay, and make it easy for them so that they stay put. There's not a use case for making an API that nobody uses.
All right. So the next one is overly chunky APIs. And I have mixed feelings about this because sometimes you need a lot of data to load a page.
Right.
And so rather than making multiple calls to the system on page load, you make one big call.
Or you server-side render potentially too. But yeah, because with that, in a lot of cases, you can get by with the underlying HTTP stuff that the browser does instead of you doing it yourself.
Yeah. Yeah. A lot of it too is like, all right, this page needs these things from 4 different resources, like from a database, from another API, from this view, like that sort of stuff put together into one. But an API is considered chunky if a single call returns an overly large object graph.
Yeah, note that that's opinionated too, because like, what is overly large? Well, in 1996, that was different than now.
Right. You kind of want to avoid exhaustive deep loading of all related entities and let the client specify what they actually want. Like I said, we have one page where it is pulling from like 4 or 5 different places.
Right.
For this one page. And so we're putting all that together into one call. But then other things within there are like you click on like the tab and it takes you to another component and that makes it separate call. So
yeah, and you're going to want to add some kind of functionality if you think that's a common use case. But from the perspective of, hey, this is an API conversation, what you don't want to do is assume that all clients use that chunky page format, right? Like they may have a lightweight version that just has a little bit of information on it. And you just want to make sure that there is a path for not beating the crap out of your system for those common use cases. Really chunky calls can be kind of slow. They can put a lot of load on the database. They can also cram the cache full of stuff, potentially depending on what's in there. So you may have something that is a very large object that gets crammed into cache, and because something in that object changed, it also transits the cache frequently as it gets invalidated. And even sometimes you can have results that are larger than what you realistically want to store in cache. So if you're bringing thousands of database records back, obviously you want to fix that with paging or something.
What I'm thinking is not like a bunch of records, but a single record that has just a bunch of stuff in it. It's like, oh, hey, we've got this API that we're reaching out and getting information from. We've got stuff in our database. We've got a view that we're looking at, and this one other place that we're pulling these different things from, putting it into one package in the API, and then sending it out.
Yeah, you're thinking a whole ostrich, not a 40-pound bag of chicken wings.
Right.
Go back to the previous metaphor that we didn't really use. I guess we did. Maybe,
I don't know. Actually, it's 2 20-pound bags, but whatever.
Yeah. Well, there you go. It was a little bit chattier than chunky, I guess. No. You also want to be aware of the user's likely reason for making a call. Their likely use case may or may not need child records to remain static during the course of an operation. So for instance, a billing operation is going to go haywire if the contents of an invoice change during that operation. If it's rolling up your bills and all of a sudden, hey, there's this new line item got added in the middle of that, that's possibly not going to be good. And so you kind of are going to want to be a little bit chunkier there so that all the stuff is there.
Or like the case that I was talking about with that page where it's like, hey, we're getting it from a bunch of different places. And rather than, it's faster to do that than to make 4 separate calls.
Yeah. I also will tell you, as far as the 4 separate calls, one other thing to consider is what the cache duration is for each of the types that are in there. Like if they have the same expected cache lifetime, that being in a chunky call is advantageous. If they have vastly different ones, it may or may not be, because those things may get cached and they're used on another page, for instance, parts of it. And so like you really, really have to look at the use case very closely, which is why this is hard to have a discussion about, because it's like I can argue both sides of this and so could you. And we're going to enjoy it too much if we continue doing that.
That is, you're very right. You're very right there. We do have a lot more points to get to in the next 15 minutes or less. So now, finally, under chunky calls, the bandwidth available to users really matters. There's a big difference between a data pipeline on the same LAN versus a mobile client out in the boonies, and you'll need to adjust your structure accordingly. Oh my goodness, I worked on one application. I didn't actually write this. I worked on it after it was written, doing like the final regression testing, because the developer who built it got a promotion to another department, and so like he left before it was finished. But yeah, so anyway, but it was a mobile application to go out to like very remote places. It was really cool, but that's what that made me think of, because it was like, oh hey, they may or may not have access. Even in like our digital age, there's places, especially in the hills of Tennessee,
or in between calls. Like if you got a series of calls happening and the third one craps out,
right?
It gets weird. I saw a discussion earlier this week that was, what was the phrase? Offline is a special case of very slow online, right? It's kind of that thing of like, you've actually only clapped once in your life. It's just the space between the claps has changed, right? It's like how you break that setup. And it's that weird, you kind of have that same thing with sequential calls happening over the network too. It's like, well, if you're not online right now, you're going to be online later. So you just have to think about that.
That is interesting.
It's a weird headspace to be in. So obviously we have this next one down, and that is overly chatty APIs.
Really? That happens?
Yeah. So the converse of an overly chunky API is an overly chatty one. And I'm dealing with one of those at work right now. Going back to the invoice example, an overly chatty API would have you download the invoice header, then make separate calls for each of the items, the shipping information, billing information, etc. And this is also really a big problem in single page apps where you don't have state management happening, where it's like, hey, I've got this thing already. And you get 2 components that need it. They both make separate calls.
Yeah. Well, this is why I like using a home component.
Yeah. This is why I tend to go slightly chattier than chunky because it's more likely that if I screw up, those calls are cached.
Yeah.
Like, I feel like that's the net under my stupidity. And I always try to keep one of those.
Mm-hmm. Yeah. I mean, there's an interesting balance, and it's really kind of dependent on your use case as to how chunky or how chatty, because it's going to be one or the other. You're either going to have bigger calls or more frequent calls, because you got to get all the data there somehow. And you want to find this balance. With the chatty calls, there is an overhead to HTTP traffic. An overly chatty application will waste a lot of CPU cycles, bandwidth, and cache by forcing the client to communicate way too frequently.
Yeah. So for the overhead, it's all that processing plus all the security stuff. Just there's a lot going on there. I typically try to say that you should retrieve a unit of work's worth of data at a time while not accurately defining what a unit of work actually is.
I was going to say, what do you define as a unit of work?
Yeah. So, like, this is a chunk of data that I can deal with as a piece.
Yeah.
With a, like a single operation happens over this data. And, it doesn't require something else to do it. Kinda. That's one of those really fuzzy terms. And you'll realize I just moved the goalposts as far as how you organize that. Because it's really going to come down to your experience. And most of your experience is going to teach you things when you make the wrong decision.
Mm-hmm. The next anti-pattern is a lack of versioning discipline. Your API will change over time. That's going to happen. You should include versioning information in the API itself. You just should also have a grace period for older API versions.
Yeah, don't change it and assume that all your users can update it in a day or a week.
Apple.
Facebook.
Oh, yeah, Facebook is the worst.
Yeah, I've got story after story on that. You need to understand that an older API version may be used for quite a while by clients who have different priorities than you do or that are under different regulatory constraints. So it may be a situation where it's like, okay, we should have this changed in a week. Well, your client's office, I don't know, their entire office staff they're all from India and they're out for Diwali while you drop this change and you're in the deep rural South and you're not thinking about that. And you're like, oh, I'm going to give them a week. Well, you actually gave them 2 days. They come back to a mess and a pile of work that's probably piled up while they were gone. And oh, by the way, they're in a Sarbanes-Oxley type environment and they have handsets out in the field that aren't going to be back in the office for a week. Like, they literally cannot deploy an update. You really have to be careful about that. Like, give people enough time if you're going to make a breaking change and have some way of letting them use the old system. Otherwise, you're gonna really, really tick people off.
Yeah, I mean, even if the API is only used internally for now, it's probably still wise to keep your older versions of the API around for a bit and verify that traffic is no longer going to them before pulling the plug. I mean, we do this with databases too, where if we're gonna, like, I'll remove a table or like a column or something in dev and then stop using it, let it go to test for like a couple of releases before I ever remove it from test. And then the DBAs handle it in production. And I don't know how long they wait, but it's a while.
Yeah. I mean, people have like scripts and stuff too. I mean, you don't know how somebody's actually using your app. I mean, I've even seen this in offices with like 4 or 5 developers. And you got this one dude in the back that wrote a script to make one particular task easier for him. And it's not even in source control because he just uses it when he's QAing. You really do not know. Once the API is out there, you don't know who's actually using it. If it's available, you know who can authenticate to it. And that's not the same thing. It's really important to be aware of that. Note that this also implies that you can track usage of the endpoints in general. If you can't do that, then you don't actually have versioning discipline.
So the next anti-pattern is improper patterns around long-running tasks. While users may be able to kick off a long-running or out-of-band task on your API, they shouldn't kick off the task and then wait on it. It gets even worse if you encourage them to poll for updates. Oh my goodness.
Yeah, that's what we used to do.
Yeah.
Because we didn't have the whole webhook thing was not as well established and across the board. And There were some weird things around that. And some people would do that. They'd kick something off and then they would have a method and it's just like keep checking, see if it's done, and get some kind of update. You really want to either have them receive a webhook when the process completes or put your process status in some kind of performant cache. What you don't want is them to continually hit and pull the database and put load on it. Because what's going to happen is as your system gets under load, people's reaction is going to be polling and it's going to pile that up and it's going to keep getting slower. Like you don't want a positive feedback loop. It's engineering. You want a negative feedback loop.
Long-running tasks should also take performance considerations into account. This means things like rate limiting or limiting the number of concurrent jobs being processed, those sorts of things.
Yeah, this is one of those places where the best thing for your API is probably not the best thing for the client. You want to nudge the client towards decisions that aren't harmful to your system.
Yeah.
Like any negotiation that happens when your system is okay, not when it's on fire.
Right.
The next one is improper use of authentication and authorization data. It's generally better to place authorization tokens and the like in headers rather than in the message body or in the path. Since these are going to be used all over the site, you don't want every single endpoint to be dealing with these things individually.
Auth tokens really should be fairly short-lived. However, you do want to allow for renewal. This helps avoid replay attacks.
Right. And the other thing too is hey, if the token expires and it's not used for a while, then get rid of it. And it's not an open, essentially a hole in the system waiting on a replay attack.
Right.
And you're probably going to want to look up authorization information from some sort of fast cache in a lot of cases, rather than hitting the database each time, unless you're using a third-party service for auth, which is actually generally recommended because auth is complicated.
Mm-hmm.
Or at least the authorization side, getting that correct, it's annoying.
Yeah. No. All right. So the final anti-pattern we have is improper or incorrect use of MIME types. And that's not improper use of memes.
Right. And it's not French mimes either, because those are silent. We don't have to worry about them.
When the client requests data, they should include a media type. When you return data, you should do the same. You should also try to honor what they request as much as possible. I mean,
if they request a CSV and it's an image, I'm not really sure how you handle that. Like that's an error. That's a 400 series error.
Yeah. That's a 418, right?
I thought I'm a teapot.
Yeah, I know. That's
well, I mean, you might as well at that point, right? Like it's going to get somebody's attention. They're going to go, what? Yeah, you probably ought to actually send the right error code, but
that's my favorite error code. When I don't know what to use, I use 418.
Yeah, you might as well. This is kind of part of having a robust API that's easy to use. The client may be using your API in an unusual situation where XML is a better choice than JSON for some reason or other. This is even more true when you start dealing with formats used for large chunks of data. So stuff like export files, images, and video. And, people go, oh, well, XML is never going to be a better choice. It's like, look, dude, I have friends that write VB apps. They can get an XML library that's clean and works. But for JSON, they're kind of hand rolling that.
Also, when you return data, you should specify the return data format, even if it's exactly what they asked for. The client shouldn't have to play guess the format with the return payload. That can be a pain.
Yeah. Because you get something back and you're like, I don't really know what this is. So let me try to open it in Excel. And if you can't return data in the desired format, obviously that's an error. I believe that is a 416. I have a note here. Yeah. Or, hey, you could just return a 420 error and put the messages, what you smoking? At that point.
Yeah.
I've been tempted to do that a few times. So guys, RESTful APIs are pretty much bog standard web technology at this point. Not only do complex front ends use them, but clients, QA, and other parts of your own system will often do so as well. While REST APIs are generally standard, there are a lot of mistakes you can make when designing them that make it harder to use your API, create excess load on the server, or just generally increase the frustration level of all involved parties, which, by the way, gets pointed right at you because you're the developer. Certain anti-patterns also look really good initially, but they end up causing problems later when your system gets more users or more HTTP-savvy integrators working with it. We hope that this brief overview is enough to save you some time up front on your next API project.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/CompleteDeveloperPodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.CompleteDeveloperNetwork.com. Thanks for listening. See you next time.